Job today is to say that we can find exact square roots and estimate square roots. First thing we're going to have to know is what are square roots. So follow along, take some notes, write down some questions when you have them. So, a perfect square. What is a perfect square? A perfect square is, this is going to be too big. Take a think about what you know about perfect squares. Perfect square is the product of a rational number multiplied by itself. So there are some words in there that we may be familiar with, and those words are product. Hopefully we know that that is multiplication. Rational number, we just learned about a number that can be written as a fraction, a decimal that terminates, and decimal that repeats, and then multiplied by itself. So we like to think about our rational numbers as our whole numbers. Here we're thinking 1, 2, and then looking at this chart through 16. So 1 will make a perfect square. 1 times 1 would be of 1. 2 times 2, remember that squaring is that multiplied by itself. 4. 3 squared would be 3 times 3, which would be 9. 4 squared, 4 times 4, which is 16. 5 times 5, which is 25. 6 times 6, which is 36. 7 times 7, which is 49. 8 times 8, which is 64. 9 times 9, which is 81. 10 times 10, which is 100. 11 times 11, which is 121. 12 times 12, which is 144. 13 times 13, which is 169. 14 times 14, which is 196. 15 times 15, which is 225. 16 times 16, which is 256. And obviously this is not where they stop. 17 times 17 has a value. 20 times 20, we know 2 times 2 is 4. 20 times 20 is 400. So kind of helps us know those values as well. These are just a list of perfect squares. Ones that are good to have memorized so that it makes the estimating and the finding exact of square roots a little bit easier. The reason they're called square roots, I just want to show you this quickly, is because if you made, we know squares have, the side lengths are all the same. So if I had a square which was 1 by 1, I have 1 square. If I made a square that was 2 by 2, so 2 side lengths there, 2 on the top, and 2 on the bottom. Bear with me here. Notice that's made up of actually 4 squares. A 3 by 3 square, it's a little bit messy and obviously isn't going to look perfect like a square, but you get the idea. A 3 by 3, notice 1, 2, 3, 1, 2, 3, all the same side lengths, is actually 9 squares. So it's called a perfect square. And then the square root would be 1 side length. So a square root, then, what is that? A square root is one of the two equal factors of a number. One of the two equal, so that's the key word there. Obviously there's factors that you multiply to make any number, but it's one of the two equal factors. So the square root, for example, that's the square root symbol, it's a radical sign. Square root of 4, I like to say what number times itself gives me 4, and I know that that's 2. So that's one way to think about it, is if you ask yourself, what number times itself? That's what I always think of when I see the radical sign, is what number times itself. then you can use this chart to help you. I would try to get it memorized, these numbers. The ones 1 through 10 will be a little easier. Above that might be a little harder. You can always check your answers. So the square root of 196 is 14. Sometimes you'll see that positive and negative, and that's just to say, well, a positive times a positive, 14 times 14 is going to be 196, but negative times a negative is also going to be 196, because a negative times a negative equals a positive. So the square root of 256 is either going to be that positive or that negative 16. Let me delete that quick. Or you just write 16. I was having a hard time with my mouse right now. And then the square root of 169. What number times itself gives me 169? And I know that that is 13. So key thing here, when you see the radical sign, ask what number times itself gets me to whatever's inside. There. So sometimes it's not a perfect square, so it's not going to be perfect, meaning it's not going to be a product of a rational number multiplied by itself. So what we can do is estimate then. So what it's going to say, what two whole numbers are closest to the square root of 8? So to solve this, you need to find the two perfect squares that are directly above and below the number, and you can use a number line if you need to. So if we made a number line, going in either direction, and we put 0 here, kind of have to use what you know about the perfect squares. So what the perfect squares I know, and if I need to go back to my chart, I can. I know the perfect squares of, let's say this is the number 2, this is 3, and this is 4. I know 2 times 2 is 4, so I know that the square root of 4 is 2. 3 times 3 is 9, so the square root of 9 is 3. And 4 times 4 is 16, so the square root of 16 is 4. I'm looking for right now the square root of 8. Well, 8 is between 4 and 9, so the square root of 8 is going to fit in. It's going to be a little bit closer to 3 than it is to 2. So that's going to be 2 point something. And to estimate, you could also plug it in your calculator and round to the nearest number when it's looking for just what is it closest to. But this question says, what are the two whole numbers it's closest to? So it's closest to 3, but it's between 2 and 3. So you could give these next few a try, pause, and move on to try these examples, or you can watch me do them and then write them down after that. It's always good to give it a try on your own though too. So sometimes you're going to use the number line, sometimes you're just going to use your chart. So I like to put in 135 right in the center. And on the outside, I like to know what is the perfect square that's largest right above and the perfect square that's lowest. So I know 100, then 121, then 144, 169. So I know that 121 is right below and 144 is right above. And so below that, square root of 121 is 11. Above is 12. It's 9 away from this. It's 14 away from that. So it's closest to 12, but it's between 11 and 12. Because the question is, what two whole numbers is it closest? So square root of 200. I know that's more than 196, which is the perfect square of 14. And it is less than square root of 225, which the square root of that is 15. So this is obviously going to be closest to 14, but the two numbers it's between are 14 and 15. So be able to know which is it closest to as well. So again, 192. I know right above that there's a perfect square of 196, which is the perfect square of 14. And below that, we have the perfect square 169, whose square root is 13. So obviously this one's closer to 14, but it's between 13 and 14. And lastly, we have the square root of 37. And again, I'm using that chart. I have it memorized. You may need to look back at your chart. So I have the square root of 37. 6 times 6 is 36. So this is between 6 and square root of 7, which is 49. Notice how I have it between 2. I didn't go all the way up to 64. It's between these two consecutive whole numbers. We are going to look at this tomorrow just to recap. You're going to see some things like this where it says the positive and negative. So this could be positive and negative. Square root of 64 is 8. You're going to see some things like this. Remember, they do or do not have an answer. And you're going to see some like this where you have to take the square root of both the top and the bottom. So be prepared to go over this in class tomorrow. We'll see you soon.